Hi, my name is Dimitri Nesteruk, and I'm happy to welcome you to this course on parallel computing with CUDA. In this module, I'm going to first of all describe the course as a whole, and then I basically want to give a historic and technological overview of GPU computation and its advancement as a domain of high-performance computing. So this module is all about the genesis of GPU computation. I basically want to talk about the evolution of GPU computing, the problems it solves, and the challenges that it presents to developers. Now, a good CUDA practitioner should know their tools, so we'll talk a little bit about what's actually required to compile and run CUDA programs. After we've taken a look at the tools that we can use for developing CUDA apps, I'll show some basic CUDA C programs. Nothing major here, just a few examples to get your feet wet. Working with CUDA, or indeed any parallel computing framework, is a bit difficult without a good understanding of the parallel computing patterns, so we'll have a whole separate module on this topic. Now, CUDA scenarios can be simple or complex, depending on the desired result, and when using the more complicated patterns, we need to have our threads interacting with each other, so we'll have a module for looking at how this works. The GPU has several different kinds of memory, so we need to discuss what these types are and what they're actually used for. Sometimes, threads need to arbitrarily read and write to different locations in shared memory. A classical example of that is something like a histogram, and bad things can happen if two threads access the same memory location at once, so in this module we'll see how atomic operations help us deal with this situation. While in most situations you would have an intuitive feeling for whether a speedup will happen when using a GPU, sometimes it's well worth checking what kind of benefits you're actually getting. And CUDA events help us with this by letting us record timestamps and thus optimize the performance of our computations. And once we're comfortable with CUDA event recording, we'll delve into the murky world of asynchronous GPU processing and the idea of using streams for a form of task-based parallelism. We'll finish off this course with a discussion of a few advanced topics, such as how to run CUDA on multi-GPU systems, and we'll also talk about the Thrust library. I just want to make a note here that in addition to some software that actually lets you compile and run CUDA programs, you will also need access to a CUDA-capable GPU to actually run the programs presented in this course.